again if you're gonna willing for you.
It only acts at the beginning.
Oh, really? Interesting. All right, 1.7 is on inequalities. Look at that. I can't even write 1.7. I write 1.17. Inequalities. Like less than, greater than, less than or equal to, greater than or equal to, but in equations. So we got a couple rules that we're going to use the whole way. If A, B, and C are real numbers, or let A, B, and C be real numbers, we're just going to assume they are. This works for regular good old numbers. A. If A is less than B, I can multiply both sides by C, and I should say, and C is greater than 0, then A times C is less than B times C. Maybe I'll call that A1. A2 is going to be if C is less than 0. If A is less than B and C is less than 0. If I do A times C, it's now going to be greater than B times C. And I think maybe just using some numbers here will help. Let's make some examples. This is the trickiest set of stuff. So let's say I've got 2 is less than 4. And I multiply both sides by 3. I get 6 is less than 12. And clearly 6 is less than 12. If I start with the same 2 and is less than 4, and I multiply both sides by -3, on the left I get -6, on the right I get -12, and I'd rather only owe someone $6 rather than $12 because $12 is lower. So -6 is higher than -12. So basically, multiplying or dividing by a negative value flips the sign. Flips the inequality. Might even be easier seeing with just some straight stuff. If I have x is less than, or x is greater than 3, let's swap sides just by subtracting and adding shit. Let's subtract x from both sides and let's subtract 3 from both sides. And I get -3 is less than -x. Because adding and subtracting still does not change the sign. So adding or subtracting does not change the inequality. It's only multiplying or dividing by a negative sign. Notice that this, if I had just taken x is greater than 3 and multiplied both sides by -1, I would have -x and -3. I should still have the same relationship. So the sign again flipped. when we multiplied by a negative, which is effectively like moving it to the other side. That's why the sign flips. All right, you guys ready to see it in action? Some more exciting stuff? Okay, I will see you do. Let's just look at some regular old linear inequalities. Look at quadratic next. Like negative 2x plus 7 is less than negative 5. I can add or subtract without flipping this, that's inequality. So I can subtract 7 from both sides, and it does not flip the inequality. I've got negative 2x is less than negative 12. I could divide by negative 2, or I could multiply by negative 1/2. I'm going to multiply by negative 1/2. Does the same thing. Cancels out that stuff over there. Over here, I've got negative 12 over negative 2, which is 6. Since I did a negative sign, the inequality flips. You can always check to see if you did it right at the end. Pick a number, so check. Pick a number that makes this true. And try it in the original. I strongly recommend you don't pick the next fucking number. 7 is bigger than 6. But then you actually have to do the calculations to see if it works. Don't pick a clown number that's close. Pick a number that's vastly different. Pick a very different number. Like in this case, I don't want 7. I'm going to try 1,000. I know 1,000 is greater than 6. When I try it up here in the top one, I've got negative 2. And I plug in 1,000 here. I've got negative 2,000 plus 7. I don't really need to do this math and figure out that this is negative 1993 to tell that this is a lot lower than that. So I at least did the sign right. I may not have the x is greater than 6 correctly, but I'm going to assume I did. If you want to check to see is the 6 correct, check it in the original, but with equal signs. Check the exact 6. Negative 2 times 6 plus 7. Does that equal negative 5? Negative 12 plus 7 does equal negative 5. So 6 was the correct value. That way you can check the values correct. And then if you want to make sure you didn't screw up the signs with doing the negative thing, you can always use a test number. So. Something else is in this section is called interval notation. The appropriate way to give a solution. I hope a math teacher watches this. If you're a math teacher, math snob. They don't like x is greater than 6 as the answer. This is not interval notation. I particularly think it makes a lot of sense. I don't have the need to change it, but I do want to show you the other form, because if you're going through the STEM fields, you will have teachers that use it and want you to use it and demand that you use it. And you'll see problems that have it in there and you'll go, what the hell does that mean? So. This means any number bigger than 6 works all the way up to infinity, right? X can equal 6.01, it can equal 6,000, it can equal infinity. So the number range that this works on is 6 to infinity. So that's how we write the numbers. The question is, what do we put around? We have two options. We can use brackets, or we can use parentheses. We can mix and match. So let me explain what each thing works for. The bracket indicates an equal part, like less than or equal to or greater than or equal to. A parentheses indicates a non-equal part. So it's strictly less than or greater than. It also goes with plus or minus infinity. So the interval notation for x is greater than 6. I have 6 that goes up to infinity. I had a greater than sign. I did not have an equal sign, so I'm going to use a parentheses on this side. And the infinity signs always get a parentheses. I hate this notation. Especially if, like, later on when this isn't infinity but it's like a 9, this actually looks like a coordinate system when you're graphing. It's a terrible fucking idea. I don't know what jackass came up with the parentheses, using parentheses for it, but they did. Let's solve some more, and so you'll see what the other kinds of notations look like. And you'll just get used to that with practice. That's all it takes. Okay, here you need to make a decision. We're going to solve it like it's got an equal sign. So where do we want the x's to go? Do we want the x's to go on the left, or do we want the x's to go on the right? Don't blur out an answer. Just think about it and do what works about West for you. Let's argue the pros and cons. If I move the x
to left.
Hold on, Jose. Let's wait. If I move the 2 x's to the left, I got to subtract it, right? I'll have a negative 6x, which means when I divide, I got a negative sign. I'm going to have to change the inequality sign. And I may forget to do that. If I add the 4x's to both sides, I'm gonna end up with a positive 6x on the right, but my x is still on the right. So, like, you gotta pick which way you wanna do it. I'm gonna go with the x's on the right because I hate dealing with the negative signs, always. Even in a regular straight equation, I hate negative signs. What were you gonna say, Josue?
Oh no, never mind. I was saying that you could like move the 2x to the left. It works better for me.
Then please do. If you like moving it to the left, please do. I hate doing the negative signs. I'm not gonna do it because even as good as I am at mathematics, sometimes I forget the fucking negative signs there and I get the wrong answer. And I'd rather like just be uncomfortable with the x on the right by adding 4x to both sides.
Yeah.
Again, you can choose what you want to do.
Okay.
And since I'm moving the x's to the right, I'm going to move the constants, the numbers to the left. I'm going to subtract the 8 over to the left. And I will have -5 is less than or greater than or equal to 6x. I can divide by 6 and I get -5/6 is greater than or equal to x. If you, at this point, if you don't like the x on the right, because let's face it, most people don't, once you get used to doing equations, we read left to right, at least in Western culture. And so we like starting with the x. If you move the x to the left and the -5/6 to the right, make sure the mouth is chasing the right fucking thing. Pretend this is like an alligator mouth. It's going after the 5/6. It needs to be going after the 5/6 at the end. Or Pac-Man. If you like Pac-Man, if you even know who Pac-Man is. Fucking old as fuck, Paxton. So, how can I write this in interval notation? If you had done it the way Josue said, by doing the -4x over here, you would have gotten straight into this without having to flip the sides like that. So both methods will get you the same answer. This means numbers less than -5/6 work, like -1, -20, -1 billion. All the way up to negative any, but -5/6 works as well. Since we have the equal sign, we're going to use a bracket. The infinity always gets a parentheses. Whoa. Let's change it up a little bit. What if I got like a 3-part inequality? Yeah, whatever, when we used to do it just to, we always added the 8 to both sides. But now there's more than, there's not just a both sides, there's a 3 sides. So if we add the 8 to get rid of it, we have to add the 8 everywhere. And now if we want to divide by 6 to get rid of the 6, (9/6) simplifies to 3/2. And if I want to write this in interval notation, the lowest number I can possibly have is 3/2. I can't go all the way up to infinity this time. I have to stop at 2. And they both have this little equal portion underneath. So we're going to do brackets on both. Let's take a look at what happens if it was something like there's a negative number there. So let's have like the -2 is less than or equal to 2x, -2x, which is less than or equal to 0. This one, this setup is actually easier to not forget to flip the signs. If I divide everything by -2, what I get is, and if I look at the 1 and the 0, and x is between them, I got to make the mouths go to the left because 0 is less than 1, or 1 is greater than 0. This is an extremely awkward way of writing it, though. So we never really leave it like that. It's best to rewrite this as 0 is less than x is less than 1. It works really well if you got like a C2 piece of paper, like really thin paper. You can actually write this 1 less than, in fact, it's, let's see if I can do it. See if I can make it dark enough. You son of a bitch. Fail. Try this again. Let's flip it over. That's a fucking scrub move. Now I'm hoping when I flip the paper over, you can still see this shit through it. See? So it's like you're basically grabbing it and just flipping it. 1 and 0 make a really good example to do it on because they look the same front and back. That was fun. Especially watching me fuck it up a few times. All right, so let's kick it up a notch. Let's do quadratic inequalities. This has a little flavor to it. We want to get the equations down to ax squared plus bx plus c equals 0. Preferably by factoring because it's easier. But if you can't do it by factoring and you've got to do the quadratic formula, it still works. Oh, maybe I should make it an inequality, huh? Or I could have less than 0 over there, something like that. We are going to solve as usual. Solve as if it's equal. And we're going to get two solutions. That's step A. Step B, make a number line with them. This is a lot easier with a number line. And then test values from each region. To see which regions match the inequality. We solve this, what do we get? If I factor that, I've got x minus 5 and x plus 3. I'm going to pretend like it's equal and figure out what, like, if I had the equal solutions, what would I get? I get x equals 5 or x equals -3. Now, what we do is we make a number line. Pick values from each region to test. 0 is always a great number to try. 0 is between those. And then pick something obnoxiously different. Like I'm going to go -1,000. And I'm going to go +1,000. It doesn't make my number line look very well, but when I'm testing these regions, do a little workspace below it. What I'm doing is I'm taking these red values and plugging them into here and seeing what I get. If you've got it in a factored form, all you got to do, we don't care about the value. We just want to know if it's positive or it's negative. That's all we care about. Because if it's positive, it's not less than 0. If it's negative, it is less than 0. So if I stick, let me illustrate it out by drawing the parentheses this first time. I don't need to add it up and figure out what these numbers are. -1,000 plus 3 is definitely a negative number. Would you guys all agree on that? Same thing with -1,000 minus 5. These are both negative numbers. 2 negative numbers multiply together to make a positive number. This region is positive. If I stick in 0, I have 0 minus 5 times 0 plus 3. And I only wrote the 0 just to make it clear what I'm doing. You get to the point when you're plugging in 0, this is just -5 times 3, which is -15. That's a negative value. And then if I do it again with the 1,000, I get a positive and a positive. Two numbers multiply together to make a positive. Now we're looking for, I go up and I check my inequality. I'm looking for things that are less than 0. I'm looking for this bad boy right here. Since the 0 worked and the other two regions didn't, that means everything between the -3 and the 5 work. And it means the solution to this goes from -3 to 5. And since we had the less than or equal to part for both of them, we're going to use square brackets for both. Yeah.
It works in the, say you were to get the R, for example, you got the positive, so that would on each side, would you use the union? Simple.
Yeah, we're going to do that next.
But that's where I tend to struggle with in the past. I would forget what's put together, what to do.
Right.
It'd be like the union would.
If you do it on the number line like I'm doing, it kind of like shows it.
Yeah. I didn't learn how to. This is kind of.
Okay, I'm glad this is helpful for you then. I want to make sure is everyone good with that so far? Are you guys ready for another problem? Does anyone need this up longer? If you do, say so. Otherwise, vamonos. Let's go with 3x squared minus 11x minus 4 is greater than 0. So if I treat this as the equality, I'm looking for 3 times -4 gives me -12. I need things that multiply to -12, but add up to -11. So -12 and 1. And I need a 3x here. And now I'm going to get rid of that equal sign. Well, no, I still need it to solve. So 3x plus 1 equals 0, or x minus 4 equals 0. And I'm going to get x equals -1/3 or 4. I'm going to say the book calls these critical points. I know they call them critical points. Why am I saying I want to say? I know they do. Let's number line that some bitch. And you don't need to make it draw to scale. You just want to have regions, there's like 3 evenly spaced regions. You want to have them in the correct order, like the lower one on the left, the bigger one on the right, but other than that, you're good to go. So now what we're working on here is we want 3x plus 1 times x minus 4 to be greater than 0. So that's what we're going to check. And we're going to pick values from each region to do that. 0's in here. 1,000 just took up too much writing. Let's go with like 100, maybe a negative 100. So I'm going to take these values and I'm going to plug them in. 3 times negative 100 plus 1. And then 100 minus 4. 3 times negative 100 is a really big negative number, and then I add 1 to it. That parentheses is negative. 100 minus 4, it doesn't matter that it's 96. The important part is that it's positive.
It should be negative 100. Or
You're right. I'm over here doing stupid shit. Thank you. Good catch. See, I told you I fuck up negative signs. I hate dealing with negative signs. So I got 2 negatives, they multiply to make a positive. This region is positive. If I plug in 0, I have 1 times negative 4, a positive times a negative. The middle region is negative. And if I plug in the 100 over here, I've got 3 times 100 plus 1 and 100 minus 4. These parentheses are both positive. So this region is positive. We wanted things that were greater than 0. So we wanted the regions that had positive outcomes. The positive outcomes are here and here.
I'm sorry. Despite the negative sign, it doesn't matter for what you multiply it. Like for what you substitute the x, right?
Right. As long as we pick 1 from each region here, plug it in. We just care about what sign it is.
Okay, got it.
I mean, you can actually go through and find the number. Like negative 3, negative 100 times 3 is negative 300 plus 1 is negative 296. And I could multiply it by negative 104. I could find out what that is. But the point is that when I do that, it's greater than 0. So
okay,
you can skip all the math part. You're just looking for the signs. I'm going to pencil in a negative infinity and a positive infinity on the ends of the graph here, because I think as you're going from left to right and how to do this as the inequality, it kind of makes it a little bit easier. So if I'm going from left to right, I start at the negative infinity sign. I'm going to write that down. It's in the positive region. And I go all the way up to the negative 1/3 and I stop. And I don't have anything in the the negative region, so I don't do anything, and I come over here and I hit the positive region again, starting at 4. And that goes all the way on to positive infinity. And now I look at my inequality symbols and see what they were. The negative infinity and positive infinity are always parentheses. We had greater than, there's no equal sign, so we're going to use parentheses for these values as well. And since there's a region in between them that we don't have, we're going to put a big fat wide U in there. This is called union. The solution is the union of these two areas. If you'd like to see it shaded in, I'm going to shade in on the area that's positive. So I don't want to include the negative 1/3 because I don't have an equal sign. So I'm going to put a circle around that to say that I don't have it, and then I'm just going to shade to the left. And I want to put a circle around the 4 because the 4 doesn't make it true. And I'm going to shade to the right. So if you see that on, if they have it on the homework, how they shade, I don't know if they do the shading in this book or not. Because they all mentioned doing a number line in their notes. That's just my thing. Okay. This is where kind of where the shit hits the fan. The rational inequalities. Rational means the ratio, means we have to the fractions. This is the one time you never clear the fractions. Very important. You just gotta fucking deal with them. You gotta keep them the whole way. And you're like, what do you mean by that, Jones? Well, let's take a lookie. If I've got 6 over x minus 3 is greater than or equal to 4. If I can't clear the fractions, what can I do about the fractions? What's the only other thing we ever do with fractions? Get a common denominator. That's exactly what we're going to go for. So let's find, make them all have a common denominator. This one only got one fraction, so it's kind of straightforward. I need this one to have x minus 3 on bottom. So I need to multiply it on top by that as well. And then I can get everything on one side. And if I get everything on one side, I just have one fraction. So I'm going to subtract this over. Subtract over. And I'm going to have -4 times x minus 3 on top. On the right side, since I subtracted everything over, I've got 0. I want to make sure everyone understands that because I did kind of a couple steps there, and I want to make sure it's clear what's going on. Okay, so we want to clean up the top now. Is everyone okay with what I did? Subtracting it over and just making it one fraction.
Yes.
At this, you good, Josue?
I said yes.
Okay, good. So at this point, we want to clean up the top. I'm going to distribute that -4. In the interest of saving some room, I'm going to write it over here to the right. -4x plus 18 over x minus 3 is greater than or equal to 0. What we do now is find where the top and bottom both equal 0. They don't have to equal 0 at the same time, but they have to equal 0. These are our critical points. We're going to do the number line and we're going to use both of those on there.
Didn't you divide by -4? So wouldn't it be -9/2?
The right side's negative also, though.
It was. Never mind. I messed up.
Good catch. Good looking out, though. All right, we don't have a lot of room to do the check. But I'm going to do some things right now. I want to do some shading on the number line right now before I get started. That way I don't forget. When we can equal a value, we use a solid point. When we can't equal a value, we use a hollow point. Like I did on this one back here. I used open circles because I couldn't use the -1/3 and the 4. One of these values I cannot use. Which one of these values can I not use in the solution? It's the 3. Why? It's 3 because it makes the denominator 0. Excellent. So I'm going to put a hollow circle around the 3. The one on top, we have the inequality has an equal portion to it. I'm going to put a solid dot there for now, just so I don't forget. You can always do it later, but if you do it later, there's a good chance you're going to forget what works. Now we just got to check regions again. There's no escaping this. So 0 is on the left. This sucks because I gotta pick a number that's close to both of them in the middle. I'm gonna pick a whole number. I'm gonna go with 4, and we'll go with 10 over here. And I'm plugging it into this right here. Let me rewrite it where I can see it. Right above it, -4x plus 18 over x minus 3 equals, I'm sorry, is greater than or equal to 0. That's what I'm plugging it into. So if I stick in 0, I've got 18 over -3. A positive over a negative means this region is negative. Yeah, I'll use a different color there. I'll use red. That's a negative region. If this region, I'm gonna have to, do a little bit of math. I got -4 times 4 plus 18 over 4 minus 3. This is -16 plus 18, +2 on top, +1 on bottom. This region is positive. And finally, if I stick in 10, I've got -40 plus 18 over 10 minus 3. The top is negative, the bottom is positive. Just because the 40 is the bigger number between the 40 and the 18, and the 40 is negative. Same with the bottom. 10 is positive, 3 is negative, so the bigger number says the sign. A negative and a positive just make a single negative. What I was looking for in these regions was the positive value. So I want this region right here. So, interval notation. I go left to right. I have nothing until I hit the 3. And I keep going all the way up to the 4.5. And then I have nothing after it. The 3's got a hollow point, so it gets a parentheses. The 4.5 has a solid point, so it gets a bracket. Any questions? All right, let's, does anybody need it up longer? Okay, 1.8. Absolute value equations and inequalities. We got 3 scenarios. When we finally get down to it, the absolute value of x equals k. the absolute value of x is less than k, and the absolute value of x is greater than k. Absolute value, I can stick in, I can say x can equal k, or x can equal negative k. So on a number line, I just got 2 points for this top one, and there's nothing between them. Those are the two values. To continue with the next part, I'm going to remind you what absolute value sign means, but with an equal sign. The absolute value of x equals c means if x is greater than 0, x equals c. If x is less than 0, x equals negative c. Because those will still give me c when I plug them in. How does that affect my b in my problem b in part c? I have the absolute value of x is less than k. This says x is less than k. And then we have the opposite sign. I could effectively say, I could write this as negative x equals c. So that's what I'm going to do here. Negative x and the k, but the sign flipped. The sign's supposed to flip. I didn't flip it. I said the sign flipped, and then I didn't actually flip it. So this ends up being, what if I change it back? What if I flip it again and I multiply by a negative? I got x is less than negative k. That looks funny. I don't want to do that. What am I doing? How am I fucking this up? That's how I'm fucking it up. When you plug in the negative on the right side, you flip the inequality. That's what I'm doing wrong. I'm like, this is wrong. I know it's fucking wrong. I'm pulling an amateur move up here. So if I put these in order, negative k is less than x, which is less than k. On a number line, it's between them. This is called the and scenario. X is less than k and x is greater than negative k. The way I remember it is less than, and sounds like and. And sounds like sandwich. Or and is in sandwich. So this is x is greater than negative k and x is less than k. That was B. C. Absolute value of x is greater than k. Greater sounds like greater. Or we're going to have x is greater than k or x is less than negative k. Which means there's two different areas. If I draw the number line here, x is less than negative k is over here. That's that one. And this one is x is greater than k. That's that way. So it's in this region or it's in that region. Greater. Less than and sandwich. I know it's a dumb mnemonic, but it works. Let's look at solving actual, like more to it than that. But I'll let you finish writing that down before I turn the page. Looks like we're going to have to extend the homework due date on 1.8 because we're not going to finish today. This is a short section, but I still don't think we're going to finish. 1.8 is relatively short. You're like, what? Extend the homework? I'm okay with that. Right? You're not okay with it?
Isn't it? It's like, oh.
Oh, yeah. Well, go through and do as much as you can. You don't have to wait.
Yeah, that's what I've been doing.
Okay.
Because what was.
Right. I like it. Let's take a look at some examples. 9 minus 4x equals 7. So this means two things. This means whatever's inside equals 7, or whatever's inside equals -7. You have to solve two equations. But now we're just down to linear equations, aren't we? -4x equals -2 on this one. If I divide by -4 on both sides, I get x equals 1/2. On this side, if I subtract 9 for both sides, I get -4x equals -16. And I divide by -4, I get x equals 4. X equals 1/2 or x equals 4. Those aren't too bad. You just have to solve two linear equations. So let's make it worse. How might you ask? How could I make an absolute value problem worse? I could have two absolute value problems in it. It looks worse. It is not. It's the same thing. I'm going to take this side. I'm going to say 3x plus 2 equals the right side without the absolute value sign, x minus 5. Or I will take 3x plus 2 and I will make the right side negative. I mean, you can go and take these apart one at a time doing pluses and minuses. And you're going to end up with, it looks like 4 equations, but 2 pairs of them are identical. So this just speeds it all up. So I'll subtract x here. And I'll move the 2 over there. I got 2x equals -7. So x equals -7 over 2. Or I'm going to distribute this above it real quick. I've got -x plus 5. So if I get my x's all on the same side, I'm going to add x to both sides. I'll still subtract the 2. Now I've got 4x. 5 minus 2 is 3. So the other answer we get is x equals 3/4. How can I be absolutely that confident that I have the right answer if I'm taking the test? I can plug it in. Yeah. Check your work by plugging into the original equation. And rather than hand waving now, we're going to actually do that. Let's make sure you guys know like what I'm saying here. So I've got 9 minus 4x equals 7. And we came up with x equals -7 over 2 or 3 over 4. So I am gonna check both.
That's the wrong equation.
You're right.
This is
That
the-
is the
yeah.
wrong equation. Fantastic. I went too far up. Thank you. Neither of those was going to work. That would have been glorious. And I would have been sitting there going, huh? Scratching my head with that, that stupid look on your face. You're like, huh? Good catch. Thanks. Thanks for saving me from looking like too much of a jackass. So let's stick in the -7/2 first. I've got 3 times -7/2 plus 2. Does that equal the absolute value of -7/2 minus 5? Over here, I've got -21 over 2. And if I want to get a common denominator, I'm going to call that 4 over 2. Which means I've got the absolute value of -17 over 2. And I'm checking these, so I'm gonna put in a question mark sign. If I do the right side, if I get a common denominator over there, -5 is -10/2. And if I put those together, I've got -17/2. Bam, those both equal 17/2. X equals -7/2 is a valid solution. Let's check the 3/4. Here I've got 9/4. And if I want a common denominator with a 4, I got to turn that 2 into 8/4. And on the right side, I got to turn that -5 into -20/4. Here, I've got the absolute value of 17/4. On the right side, I've got the absolute value of -17/4. But conveniently, the absolute value makes them both positive, 17/4. That's a valid solution as well. I will start you on showing you how to start the next problems where there's inequalities. Because we only got 7 minutes left, but I want so that you can get more homework done if you work ahead. Let's have 4x, absolute value of 4x minus 6 is less than 10. When we go to do it, we keep it the same way it is. 4x minus 6 is less than 10. Less than is an and sandwich. So I'm going to make it -10. If you do them separately, you would have 4x minus 6 is less than 10 and 4x minus 6 is greater than -10. And we'll work through this example on Wednesday. But now this isn't anything different than what we did 45 minutes ago. Okay. You just have to satisfy both regions on the graph. If it's greater than sign, like let's say we had 2x minus 5 is greater than, I don't know, fuck it, let's go with greater than 5. Why not? Greater sounds like an or. This is an or scenario. It's not going to make the sandwich. 2x minus 5 is greater than 5, or 2x minus 5 is less than -5. In both cases, you do the sign change with the negative. They go together. It's a package deal. We did the sign change here with a negative. Package deal.
All right. I just remember. So I mean, I don't know if you have time for, to explain me this, but when the sign is negative, something's happened. Something happened. I don't remember what it was.
I just told you, we flipped the sign.
No. But I mean, for example, the one on top that is like absolute value of 4x -6, and this one is smaller than the 10. If the 10 is -10, what happens?
We'll cover that on Wednesday. That's
Oh,
a
okay,
special case. We will hit that. Good question.
Okay.
What happens when you're like, what if I say this is less than -10 is what he's asking?
Yeah.
Well, I'm saying a positive number is less than a negative number.
Oh, okay.
That's never true. It's a special case. We'll get to that.
Okay, yeah. Thank you.
Let's wrap it up. Gives you, you're out 4 minutes earlier today. And you have almost everything you need to do all of 1.8 now.
Have a good day.
You too. Have a good weekend too.
Before you go, like, I don't know if you remember that you put a extra credit assignment today. No, it was for yesterday. No.
Uh-huh.
Yes, I guess it was from yesterday. But it is actually the program is trying to do to make it like it is an assignment or not extra credit. Like it's like 20. I mean, like 19 of 20, for example. It's gonna take up points of the overall score.
Do not worry. I will make sure that in the end, the extra credit is only going to be extra credit.
Oh yeah. Because I went through it.
Promise you, you are not going to get screwed if you don't do it, and you'll get extra credit if you did do it. And you,
Okay.
I know you did some of it.
Yeah, I did half of
Yeah.
it. Yeah.
So don't worry. I won't screw you.
You will be on Sunday in the Starbucks, or you're not gonna be?
Yes, I
able to
will.
be?
I will be.
Like, what is your schedule? Like
8 to
Sunday
11.
8 to 11?
Yeah.
Sunday and Saturday, or only Sunday?
Saturday, I'm working with other students.
Okay,
I
Sunday.
mean, you
then.
can come on Saturday, but I got to give them priority.
Okay.
And it's on the Caldwell and Demery.
Cool, Demery. Is it one of these? Because I'm not from Tulare. Yeah.
That's where I'm going to be.